Assalamu alaikum. Bismillahirrahmanirrahim. Today I will solve Cambridge International A-Level paper, paper 3, May June 2022. Question number 1, solve the equation ln 2 to power 2x plus 3 equal to 2x plus ln 3, giving your answer correct to 3 decimal places. Here the equation is given. Firstly, we write this equation ln Bismillahirrahmanirrahim. Today I will solve Cambridge International A-Level paper, paper 3, May June 2022. Question 1. Solve the equation ln e power 2x plus 3 equal to 2x plus ln 3, giving your answer correct to 3 decimal places. Firstly, we write this equation as it is ln e power 2x plus 3 equal to 2x plus ln 3. Now we shift the ln 3 from right to left side. Therefore, that equation becomes ln e power 2x plus 3 minus ln 3, that's equal to 2x. The logarithm rules, log x minus log y, that is equal to log x over y. We use this rule. Therefore, ln e power 2x plus 3 over 3 equal to 2x. Now we convert it into index form, exponential form. We know log x base a equal to y, that can be written as a power y equal to x. Therefore, we convert into exponential form. We see that here the base of this ln is e. Log base e can be written as ln. Therefore, e power 2x is equal to e power 2x plus 3 over 3. Now we simplify this. We cross multiply. 3 into e power 2x is equal to e power 2x plus 3. So this is plus 3 is there. Now we shift e power 2x from right to left side. We get e power 2x minus e power 2x equal to 3. Therefore, that is equal to 2 e power e2x equal to 3. Now e power 2x equal to 3 over 2. And this equation becomes e power 2x equal to 1.5. Now to find the value of x, we taking ln on both sides. Therefore, ln e power 2x equal to ln 1.5. Therefore, ln e is equal to 1, that is equal to 2x, and 2x equal to ln 1.5. Then x will be equal to ln 1.5 over 2. We calculate it. Now ln 1.5 divided by 2, the answer is 0.20273. At 3 decimal places, answer 0.202, and the neighboring digit is more than 5, therefore it becomes 0.203 is the answer. Here the cos 2 theta, we know that the cos 2 theta is equal to cos square theta minus sine square theta, or cos 2 theta can also be written as 2 cos square theta minus 1. We can see the formula from the formula sheet. Now we write 3 into cos 2 cos square theta. Now that is equal to 3 cos theta plus 2. Now multiply 3 times 2, 6 cos square theta minus 3 equal to 3 cos theta plus 2. Then it becomes 6 cos k theta minus 3 cos theta and minus 3 and minus 2, it becomes minus 5 equal to 0. Now we substitute cos k theta equal to t, and that equation becomes 6t square minus 3t minus 5 equal to 0. And this is the quadratic equation in terms of t. Now we use the quadratic formula, that is equal to minus b plus minus b square minus 4ac over 2 times of a. Here is a, and that is considered as b, and that is considered as c. Now we write it, t is equal to minus minus 3 plus minus square root minus b square minus 4 times of ac. This is c. Now a is 6 and c is 5. Therefore, and over 2 times of a, 2 times of 6. Now this equation becomes 3 plus minus 9, that is minus 5, and 9 minus minus plus 5 for the 20, 26 by 120 over 12. And that is equal to 3 plus minus square root of 129 over 12. P will be equal to 3 plus square root of 120, or t equal to 3 minus square root of 129 over 12. Now 3 plus square root of 129 over 12, and that is equal to 1.196. And second value, we calculate it, 3 minus 3 minus square root of 129 over 12, that is equal to minus 0.6964 theta. Now the t will be equal to cos theta. Now we put the value cos theta there. Now we get 1.196, or cos theta is equal to minus 0.6964. Here the value of the cos theta is given 1.196. We know the range of cos theta values is less than 1 and greater than 2 minus 1. Therefore, the solution of this cos theta is not possible. No solution for this case. Now we find the second value. Theta will be equal to cos inverse minus 0.6964. We can write it as alpha equal to, we take the acute angle value cos inverse 0.6964. We calculate it. Now we take cos inverse of 0.6964. The answer is 45.86 degree. 45.86 degree, and that is equal to 45 point. Now here is the theta will be equal to, so the negative of cos theta is in the second and third quadrant. In the second quadrant, theta will be equal to 180 minus alpha, that is equal to 180 minus 45.86 degree, and theta equal to, in the third quadrant, theta will be equal to 180 that is theta. This is equal to 180 plus alpha. Now 180 plus 45.86 and 225.86. Now here we calculate it. Now theta will be equal to 180 minus 45.86. Now 180 minus the answer, I get 134.13, 225.8. The neighboring digit is more than 5. You can write to 225.9 degree is the answer. Question 3. The polynomial ax cubed plus x squared plus bx plus 3 is denoted by p of x. It is given that p of x is divisible by 2x minus 1. When p of x is divided by x plus 3, the remainder is 5. Now here is find the value of a and b. Here the polynomial is given. Now we write it p of x is equal to ax cubed plus x squared plus bx plus 3. Now that px is divisible by 2x minus 1, therefore let we suppose that 2x minus 1 equal to 0. It means x equal to 1 over 2. Now, this polynomial is divisible by this. Now we can write it as p of 1 over 2 will be equal to a times 1 over 2 power 3 plus 1 over 2 whole square plus b into 1 over 2. And p of 1 over 2 will be equal to remainder, and the remainder will be equal to 0 because it is exactly divisible. Therefore, we shall write it 0 equal to 1 over 2 cube 1 over 8 a plus 1 over 4 plus 1 over 2 b and plus 3. Also, we have to write here plus 3. Now we multiply this equation by 8. We get multiply by 8. Therefore, we get 0. 1 over 8 multiply 8, it becomes a, and 1 over 4 multiply 8, that is equal to 2. 1 over 2 multiply 8, we get 4b. 3 multiplied by 8 plus 24. Now here a plus 4b will be equal to 26 minus 26. To shift this value on the from right to left side, we get a plus 4b equal to minus 26. Now the second statement, when p of x is divided by x plus 2, the remainder is 5. Now here p of x ax cubed plus x squared plus bx plus 3. You see that the x p of x is divided by x plus 2. The remainder is 5. We use the factor theorem. In the factor theorem, when we put the value x plus 2 equal to 0 and x equal to minus 2, when we put x equal to minus 2 in this polynomial p of minus 2, we get the remainder that is equal to 5. And use this formula from the factor theorem. Therefore, p of minus 2 equal to 5. Now, p of minus 2, that value will be equal to p of minus 2 equal to a times a into minus 2 cube plus minus 2 square plus p into minus 2 plus 3. Now, the value of remainder p of minus 2 is equal to remainder that is equal to 5, and that is minus 8 a cube plus, minus 8a plus 4 plus minus 2b and plus 3. That is minus 8 minus 2b, the minus 8a minus 2b, and plus 7 fifth towards right side. From right to left side, we get minus 2. Therefore, 8a plus 2b will be equal to 2. Now we take common 2 as a common. Now, therefore, 4a plus b equal to 2, and that is, it would become 4a plus b equal to. Now we put the value b equal to 1 minus. This is the question 1 and this is the question 2. Now put the value of b, the equation 1 here, a plus 4 into b is 1 minus 4a equal to minus 26. That is equal to a plus 4 minus 16a equal to minus 26. That value becomes minus 15a equal to minus 30 and a will be equal to 2. Now this value of a, put value of a in equation 2. Now we get b will be equal to 1 minus 4 times of a, 4 to 2, and 1 minus 8, and b will be equal to minus 7. Is the answer. Question 4, the equation of curve is y equal to cos cubed into square root of sin x. It is given that the curve has one stationary point in the interval x is greater than 0, less than pi over 2. Find the x-coordinate of this point. Giving your answer correct to three significant figures. Stationary points is the turning points of the curve. And the turning points as exposed is the curve. This that turning point of the curve, the gradient of the tangent at this point is 0. To find the gradient of tangent, we take the differentiate on both sides of this equation and we find the dy over dx. Now we take derivative of this function y equal to cos cubed square root of sin. To take derivative, we use the product formula of derivative. And here the product formula of derivative is d over dx of u into v, that is equal to v into derivative of u plus u into derivative of v over dx. And here we use this formula, therefore dy over dx will be equal to that v is the square root of sin x, we write it as square root of sin x into derivative of first function, that is 3 cos square x, and then again the derivative of base, that's equal to minus sin x plus 2, there is u is considered as cos cube x into derivative of second function. The derivative of sin x will be 1 over 2 sin x and the power of minus 1 over 2 minus 1. And then again the derivative of the space, the derivative of the sin x will be cos x. Now the equation becomes, that is minus 3 times sin power 3 over 2 x cos sin power 1 and 1 over 2 becomes 3 over 2. And that is cos square x plus 1 over 2 cos power 4x into x sin power x 1 minus 1 over 2. Now we're taking cos square x as a common, we get minus 3 sin power 3 over 2x plus 1 over 2 cos square x. Cos square x is as a common, therefore cos square x becomes cos square x over sin x square root. Now, 2 square root of sin x is taken as a LCM for of this fraction. Now 2 into sin x, therefore the value becomes 3 into sin power 3 over 2 into square root of sin power 3 over 2 into square root of sin x power 1 over 2, and that is 2 times 3 6 multiplied 3 also. Now here plus that value is written as it is cos square. Therefore cos square x into minus 6 and sin power 3 over 2 plus 1 over 2, that value becomes 4 over 2 is equal to 2. Therefore we can write sin square x plus cos square x over 2 square root of sin x. Now to find the stationary point, we take dy over dx equal to 0 for the stationary point. Now we want it for stationary. Now here we see that the two factors, this expression will be 0 equal to 0 when cos square x equal to 0 or minus sin square x plus cos x equal to 0. Now sin square x or cos square x. Now we can write it as cos square x equal to sin square x 6 sin square x, and we can write it as sin square x or cos square x equal to 1 over 6. Now sin over cos, that value equal to tan square x equal to 1 over 6. Therefore tan x will be equal to plus minus square root of 1 over x. Here to find the value of x, we take the 6 angle. That angle will be equal to alpha, and that is will be equal to tan inverse square root of 1 over x. We can calculate the value. So we put the value. You can see there is the shift, and that is tan inverse, and that is square root of 1 divided 6, that is 4, that is equal to 0.3875. 0.3875. Now we have to take 3 as a figure. That value will be equal to 0.388. Now the range of this angle is given here. Is you can see the limit is 0 to 5 or 2. It means the angle will lie on the first quadrant only. Therefore, we take only the positive value, and therefore theta Lx will be equal to alpha, and that is will be equal to 0.388. But the value of second value here, cos square x equal to 0, then cos x will be equal to cos x will be equal to 0, then x will be equal to cos inverse 0, and the cos inverse 0, the x will be equal to pi over 2 and 3 pi over 5 over 2 and 3 pi over 4. But this value will not lie in the range of the angle given. There is the angle range is given 0 to pi over less than pi over 2. Now therefore the only answer. Question 5. By sketching a suitable pair of graphs, show that equation ln x equal to 3x minus x squared has one real root. The, here is two graphs we will draw. First is the logarithm graph, second is this the quadratic graph. Now y equal to if y equal to ln x, the shape of this graph, we should remember the graph shape of logarithm and quadratic graph. The logarithm graph starts from minus infinity towards the to infinity, but this it shows that it never meets the y-axis. Now we see that it cuts the x-axis at which point we take ln x equal to 0, therefore x will be equal to 1. Now that is the point where the graph intersects the x-axis. Now the second graph of 3x minus x squared, this is a quadratic graph. The shape of this graph should be this. Now we find the roots of the graph by 3x square, 3x minus x square equal to 0, and if from this we can calculate the point the graph intersects x-axis. Now we take x as a common, x3 minus x will be equal to 0, x equal to 0, and x equal to 3. Therefore, graph from it passes from the 0 to 3. And this is the shape of the graph. And we see that the both graph intersects at one point only. This is 0.3 and this is 1. And it intersects at point 1 point. And if the graph intersects one point, it shows that only one will do. Okay. Now the part B, verify by calculation that the root lies between 2 and 2.8. Firstly, we make the function shift all values from right side towards the left side. We shift all values from right side towards the left side. The value ln x minus 3x plus x squared, and that is equal to f of x. And after this, we put the value in this equation. Firstly, we put f of 2 in the equation and then f of 3 in this equation. We put here ln 2 minus 3 into 2 plus 2 square. We get ln 2 minus 6 plus 4 f of 2.8, and that is equal to ln 2.8 minus 3 into 2.8 plus 2.8 whole square. Now after finding this value, we see that the what will be the value of f of 2 and f of 2.8. Now we calculate. Now the ln2, we take ln2 minus, here is minus 6 plus 2, minus 2. Now the value is minus 1.30. Here the value is negative 1.30. That is less than 0. Now we find the second value ln 2.8 minus 3 multiply 2.8 plus 2.8 square. Now the value is 0.4696. 0.469. That value is greater than 0. Therefore, the roots will lie in between interval because f of 2 is less than 0 and f of 2.8 is greater than 0. And suppose we suppose that this is the curve, the root lies, suppose this is the root, and if this we see that here the before this root value is negative, after this root is value is positive. If the sign change, it means the root lie in between. Suppose that value is 2 and that value interval is 2.8. Therefore, uh, at 2 the value is negative, at 2.8 is positive. The roots lies between 2 and 2.8. Part C, use the iterative formula x n plus 1 equal to 3xn minus ln x square root of this value to determine the roots correct to two decimal place, give the result of each iteration to four decimal place. Here the formula is given. Firstly, we have to find the initial value of this iterative formula. Now, suppose that x1 is the initial value, and that value will be lie between 2 to 2.8 because the root is lie in between 2 to 2.8. We take the middle value of this, therefore x equal to 2.4 is the initial value of the iterative formula. Now the x2, to find x2, here we can write x1 plus 1 and that is x2. Therefore, that it becomes 3x1 minus ln x1 square root. Same as the third value we can calculate is 3x2 minus ln x2 square root. We continue write this formula until the values of these values become same. Now we check what will be the value of this x2. Now put the value 3 multiply 2.4 minus ln 2.4. Now this value in the calculator we can calculate by making a formula, and in the calculator we put this x is x equal to 2.4 and that is value considered as answer, and after this we put in the calculator 3 into answer minus ln answer, and that's square root. From this put these value in the calculator, we can calculate easily other values, next other values. I put it 3 into 22.4, 2.4 minus ln 2.4. Now we get 2.51. And the next value by using the formula, this formula in the calculator, value of x3, 3x square minus ln x2, we will put 2.51 514 in this equation. Now, 2.514 8 6. Now you can write 8 6 is 9. We have to write equation value 4 decimal places. Now for the next value, we find the same as 3 into 2.5149 ln 2.5149, and this value is 2.57339. 339 means 440. Now we can write next value, put again in the formula 4 value is equal to 2.6028 60287. Now you can write 289. You can write 289. 29, sorry, 29. And same as the value of x5, we already have 2.6176. 2.6176. And the next value, we press equal sign, we get 2.6250. 2.62, 2.6250. 2.6286. 2.6286. Same as next 2.630, 2.6314, 2.6318, and same as 2.6320. And that value 2.20 is repeat again 6322, 6322, and you can see that 2.632 value you will get 2.6322. Therefore, 2.632 is the answer. Now we can write 2.632. The answer remains same. 2.632. Next, you can see that 2.6323. 2.6323. Now we can write it as continue 2.6323. Add that value, the alteration value becomes same and no change in this value. This is the answer. Question 6. The variable x and y satisfy the differential equation dy over dx equal to x into e power y minus x. And y equal to 0, x equal to 0, solve the differential equation obtaining expression for y in terms of x. And this is the differential equation. Now, to solve this, firstly we separate the same variable and we shift the y variable shift from right to left side and variable x from left to right side. So dy over dx that is equal to in the right hand side we can write it x into e power y into e power minus x. Now we shift the terms having variable x from left side to right side. And here x into e power minus x into dx and the variable the term is having variable y to shift from right to left side. Now we can write dy over e power y. That value becomes e power minus y into dy and that is equal to x into e power minus x to dx. Now we integrate it both sides and integrate this. We get e power minus y over minus 1. Now the integration of e to x dx equal to e power ax over 2. This is the formula we use here. Now the term x into e power minus x dx, we use the product formula of integration. And the product formula of integration is given in the formula 2. Now x into e power minus x dx. Now we use the formula where the first term is taken as x is first term is taken d into is x and d power dx is taken as second term with e power minus x. And to take the first term, we use this e power minus x is taken as first term. Now firstly we find where dv and dv over dx will be equal to 1. Now second we can write it as dv equal to e power minus x into dx. Now we take integrate. Now we integrate both sides. Get integration e power minus x and we get v equal to e power minus x over minus x. This is equal to v equal to minus e power minus x. Now to solve it using the product rule, and that is equal to x into e power x, which is equal to uv minus integral of v into dv over dx into dx. Now we put the value from above. Now here v is equal to x, v is minus e power minus x, minus one here, minus integral v is minus e power minus x, dv over dx is 1, and we write dx as it. Now we can write it as x into e power minus x plus integration of e minus and integration of x e power minus x and put the constant here plus c. Now this value becomes minus x e power minus x minus e power minus x plus 2. Now this value, substitute this value in this equation. Now the value x integration of x into e power minus x is minus x into e power minus x and minus e power minus x e power minus x plus 3. Now to find the value of c, we put the value x equal to 0 and y equal to 0 that is given in this question. Now put the value x is 0, y is 0, now that becomes e power 0, that minus 0, x is 0, that term becomes 0. Now with e power 0, we can write it as plus 2. Therefore, minus 2 will be cancelled and we get c equal to extinction minus e power minus 5 equal to minus x e power minus x plus e power minus x. This is the general expression of this differential. And you can write it as minus 1 over e power y minus 1 over e power x 1 over e power x into x over e power x. Now we can write it 1 minus 1 over e power x into, we can write it as minus e power minus. Now we take common here, minus e power minus x is equal to x plus 1, and can be written as minus e power minus 1. So we can write e power y equal to 1 over e power x into x plus. So this equation can be written as e power y into x plus 1 e power x. We cross multiply this and we get e power x over x plus 1 equal to e power. To find the value of y, we take log on both sides. Log dy, and that is log e power x over x plus 1. Now that is equal to ln e power y is equal to ln e power x ln x plus 1. And we use the rule L a into b can a over b, a over b can be written as ln a minus, use the rule here. Now therefore ln e is, we can write it as y into ln e. And this can be also written x into ln e minus ln x plus 1. The power of the log becomes sufficient by using this rule e power x ln when that can be written as x into ln. This is the formula we use here. Now ln is 1, we can write it 1. And that is ln is 1, therefore that ln. Part B, find the value of y when x equal to 1, giving your answer in the form of a minus ln b, where a and b are in integers. Now there y equal to x minus ln x plus 1, this is the equation. Y equal to x minus ln x plus 1. Check it. X minus ln x plus 1. Now we put the value x equal to 1 in the equation. Very simple. It was 1 minus 2 and 1 plus 1 becomes 1 minus 7. We have to write in the form, therefore a is equal to 1 and b is 2. Okay. Now go to the next question. Question 7. The equation of a curve is x cubed plus 3x squared y minus y cubed equal to 3. So that dy over dx is equal to x squared plus 2xy plus our y squared minus x squared. Right? So we see that derivative of x cubed is very simple, 3x squared plus derivative of 3x squared y. Now we use the green to v formula. Okay, here dx. And the formula we write it as v as it is, and derivative of first function plus first written as it is derivative of second. A which we use, and we take the derivative of first function. Now this is 6x and y as it is. Okay, plus and then we write 3x square as it is, and the derivative of y is 3y over 3x, because the derivative is variable structure. Now next part next is minus y cube. Now y cube we take derivative of y cube is 3y square, and then again we take derivative of the base. Here is the base is y. Now we can write it as the derivative of y 3y over 3y. Okay, now the d over dx equal to 0. The next is the 3x square is written as it is plus 6xy plus 3x square into dy over dx minus 3y square dy over dx equal to 0. Now check the 3x square plus xy square get minus 3x square minus 6xy, and we take the common, sorry, minus 3, we get x square plus 2xy over equal to 3x square minus 3y square. Okay. Now here minus 3 common, now we get x square plus 2xy. Now we take as minus 3 is also common here, then it becomes x minus x squared plus y squared. So you can write y squared minus. Therefore, dy over dx will be equal to x squared plus 2xy over y squared minus x squared. Now part B, find the coordinates of the points on the curve where the tangent is parallel to the x-axis. Now, here, this is the equation of the curve is already given, and derivative, we already proved this, dy over dx equal to y x plus 2xy over y. Now, here's the curve when the tangent is parallel to x-axis. Now, suppose this the shape of the curve, and this is the tangent line, and this is parallel to x-axis. The tangent line is parallel to x-axis. The gradient of this tangent will be 0. It means dy over dx will be equal to 0. Now here the dy over dx of this curve is given this, therefore we take as a equal to 0. Now the gradient of tangent is n, and with dy over dx, and that will be equal to 0, and with the coordinate points on the curve where tangent is parallel. Now we put the value here. This is x squared plus 2xy over x y squared minus x squared equal to 0. Now the equation will be 0 if x squared plus 2xy equal to 0. Then to take the common, x into x plus 2y, that's equal to 0. Either x equal to 0 or x plus 2y equal to 0. Now it's equal to 0 to find the coordinate of the point on the curve. We put this value in this equation of the curve. Now here is the equation x cubed. Now we write it as 0 cubed plus 3 times x squared. This is the equation of the curve. We put the value. Now x 0 cubed plus 3 times 0 squared into y minus y cubed equal to 3. Okay. Now we have it. So 0 plus 0 minus y cube equal to 2. And this y cube will be equal to minus 2. Now the value y equal to minus 3 2. Now we calculate it. Now where 2 root of minus 3. Now it is minus 3. Okay. That's equal to minus 1.442. Minus 1.442. Now x plus 2y equal to 0. Now we put x equal to, sorry, 2y equal to minus x. What's the value here? Now x equal to minus 2y. Now we put this value in the equation of the curve. Is x cubed plus 3 times x squared y minus y cubed equal to 3. We put the value of x here. That is minus 2y whole cube plus 3x is minus 2y whole square into y minus y cube as it is, and that is equal to 2. Now we can write minus 8y cube plus minus 2 square plus 4, 4 times 3 is 12, y cube minus y cube equal to 2. And that value becomes minus 8 from minus 9 plus 12 plus 12y2 equal to 3, and we get 3y2 equal to 3. Now look at what it says, y2 will be equal to 1. Now the value of y will become y2 is equal to 1 by 2. Now the coordinates of y and x and this value are put in this equation. So the equation means now x plus 2 into y equal to 0, then x plus 2 equal to 0, and then x equal to minus 2. Therefore, the coordinates of this minus 2 and 1 there, the coordinates are at x equal to 0, that is x equal to 0, the coordinates of this point 0, minus 1.442. And these are the coordinates where the tangent is parallel to x. Now, sorry, this is plus 1. This is plus 1. Question 8, let f of x equal to x squared plus 9x over 3x minus 1 into x squared plus 3. Part A express f of x in partial fraction. In the partial fraction, a fraction is resolved into two or more than two fractions, where the f of x is given, and that value is x squared plus 9x over 3x in 1 from x squared plus 3. We see that the denominator 3x into x squared plus 3, there are two factors. Therefore, we resolve this fraction into two fractions. So we can write it as denominator 3x minus 1, and the denominator of the second fraction is x squared plus 3. And here is if the denominator is a linear, then the numerator it will be constant. And same as there is the denominator is a quadratic, then we will in that the numerator is in linear. Therefore, we can write it px plus c, and b and c are the uh, constant numbers. Firstly, we multiply the equation by x 3x minus 1 into x squared plus 3. And now we multiply this, we get x squared plus 9x equal to a times of, and we multiply 3x minus 1 into x squared plus 3. Now we get x squared plus 3 because 3x minus 10 we cancel. And then next is dx plus 3 can be written as into 2x minus 1. Okay, now we see that to find the value of a, b, and c, this is the identity, and we put the value, some value to find a and b. Now here is the, if the denominator is given as linear, now we take 3x minus 1 equal to 0, and we get x equal to 1 over 3. If the denominator is linear, that value to put in this identity, we will find the value of a. Now to find a, we put here, we can write it as to find a. Therefore, we put the value in this identity, we get 1 over 3 whole square plus 9 times into 1 over 3 equal to a into 1 over 3 whole square plus 3 plus 3 into 1 over 3 into plus 3 into 3 into 1 over 3 1. Now that value becomes 0 because 1 minus 1 is 0, like it as, and that is 1 over 9a plus 3a. Okay. Now here is the 1 over 9. We write it as plus 3 times 9 3 times 3 is 9. So, now for this will be equal to 9 3 are 27 plus 1 28 or 9. So we just value so second common 1 over 9 plus 3. So that will be equal to 28 over 28 over 9. In that case will be 10. So we get a is equal to 1. Okay. Now to find the value of B and C, uh, we use this identity and comparing the coefficient. Where the identity is given, this is the identity x squared plus 9x equal to ax squared plus 3 times a plus 3, and we multiply this 3b x squared to get minus 1 dx. Now 3cx, next is 3cx, next is minus 3, 3. Sorry, minus 1. Here, minus dx, and this is minus 3. Okay. And the next is now comparing the coefficient of x squared. Here is the coefficient of x squared is 1, we write it, and the coefficient of x squared is a. Here is plus 3b. Now we can find this value of a. We put the value of a is 3. So we put 1 plus, and that is 3b, and yes, b will be equal to 1 minus 1 0. Okay, now b will be equal to 0. Now comparing the coefficient of here is 9 equal to minus 3x plus 3c x. Therefore, the coefficient of x is minus 3 and plus 3c. Here, b is 0 given. Okay, now for here, now 9 is written as it is plus 3 times c. Therefore, c will be equal to 9 over 3, that is equal to 3. Now, put the values in the equation 1, 1 plus 9x over 3x minus 1, 3x minus 1 into x squared plus 3. That is equal to a over 3x minus 1, and a is there is 1, and bx plus x squared plus 3, and bx there is x dx. Now the b is 0. Now we can write it 0. B is 0. Therefore 0x plus c is 3. Now b part means find integration 1 to 3 f of x dx, giving your answer in simplified exact form. Now this is the function. We find the value in the partial fraction here. Now we integrate f of x. Therefore, now f of x is equal to f of x into dx. The limit is 1 into 3. Now we can write f of x. We can write this value, integrate 1 over 3x minus 1 into dx, and reduce limit 1 into 3, and just integrate 1 into 1 to 3, and 3 over x squared plus 3 into dx. Now this limit is given, and 1 over 3x minus 1. Now we use the integration formula from the formula sheets. We can see the formula. The integration of 1 over ax plus b, that's equal to, oh, that's equal to 1 over a into ln dx plus b. Now here, we use this formula. Now that is equal to 1 over 3 into ln 3x minus 1. This is 1 and 3 minus 1 and 3. Okay. Sorry, plus 1 and 2. Plus 1. Now here, now to integrate this plus 3. Now, 2 over 15. Now 1 over x squared plus 3. You know 1 over x squared plus a squared integral of this dx x squared plus a squared. The integration of this will be equal to 1 over a tan inverse x over a. Okay. Now here we use the formula. This formula now we can write it as 1 over x squared plus a root of 3 squared. Now that here we write it 1 over 3 into ln 3x minus 1, 1, 2, and plus 3 into 3. We use this formula 1 over x squared plus a squared dx equal to 1 over a. Now here we say 1 over under root 3. We can write it. Now the at 1 over x squared plus a squared, that's equal to tan inverse x over a. X is square value is 3. Now we put ln 3 into 3 is 9 minus 1 minus, and we put 1 ln 3 into 1, 3 minus 1. Okay. Now plus, that's equal to 3 over under root 3. That can be written as under root 3. And tan inverse 3 over under root 3 minus 2 tan inverse 1 over under root. Now that value is 1 over 3 into ln 8 minus ln. Now this value is 3, sorry, this is 3 in the square root of 3. Now we can write it as square root of. Now this is the 3 under 3. Now, sorry, this is the square root of 3. Now we write it square root of 3. Now here, now 1 over 3, this is ln 8 minus ln 2. And plus square root of 3 is taken as a common. We get tan inverse and write it as square root of 3 minus under root 3 tan inverse 1 over square root of 3. Now we can solve 1 over 3, that is ln 8 over ln minus ln 2 can be written as ln 8 over 2. And that is 1 over 3 ln 4. And that value becomes 1 over 3 ln 2 square. Power of the logarithm can be written as a coefficient of the logarithm. Now we can write 2 over 3 ln 2. Okay. Now next is the plus square root of 3 into 10 inverse square root 3. Now we calculate these values by calculator. There is Greater now. Find it tan inverse. Now tan inverse square root of 3, which is square root 3, now equal to 1 over 3 pi. That's equal to 1 over 3 pi. Now, it's under root 3, which is already taken as a common, therefore we write it here. Now we find the value tan inverse 1 over under root 3. Now tan inverse 1 divided square root 3, now we get 5 over 6. The value is 5 over 6. Okay. Now 5 over 6, we write 5 over 6. Now this can be written as plus under root 3 over 3 pi minus under root 3 pi over 6. You can write it as plus 5 over 3 6 into under root 3 and 6 pi minus 3 pi over 6. Now under root 3 will be equal to root 3 into 3 pi over 6. 3 times 2 we get the answer 2 over 3 ln 2 plus square root of 3 over 2 pi. Now divide it from root 3 and that is equal to 6 and that is 2 pi. But we become under root 3 over 6 into question 9, the lines L and N have vector equation r equal to minus I plus 3j plus 4k plus lambda into 2i minus j minus k and r equal to 5i plus 4j plus 3k plus mu into ai plus pj plus k respectively, wherein b are constant given that L and N intersect. And this is the vector equation L and this is the vector equation N. We write as the L vector equation here and we write this in column vector form. In the column vector form, R is the can be written as x, y, z, and the next is the minus I plus 3j plus 4k, which shows the position vector, and that is the position vector is the minus 1, 3, and 4. We write the coefficient of I, j, k, and as it is plus lambda is written as it is, and this is the direction vector, and the coefficient of ijk is 2 minus 1 minus 1. And same as we write the question, vector equation n, and we write this also column vector form, and this is the column vector form x, y, z, and that will be equal to n is the coefficient of position vector is 5, 4, 3, and plus and the plus mu into the direction vector is ai plus bj plus k. Now we write it as 3b1 percent of I a percent of k b and percent of k. Now we this equation can be written as minus 1 plus 2 lambda and 3 minus lambda and 4 minus lambda. This equation can write it as here, and this also can be written as 5 plus mu A, 4 plus mu B, and 3 plus mu 1 mu. Okay. Now XYZ is minus 1 plus 2 lambda, 3 minus lambda, 4 minus lambda. Now we like the fourth equation, we get minus 1 plus 2 lambda, 3 minus lambda, 4 minus lambda. That is equal to 5 plus mu A and 4 plus mu B, okay, and 3 plus mu. Therefore, we get three equations. 2 lambda minus 1 equal to 5 plus mu A, and second equation is 3 minus lambda equal to 4 plus mu B, and 4 minus lambda will be equal to 3 plus mu. And we find the values of mu and lambda from these two equations and put in their value in the third. And if it satisfies, then these two lines will intersect in each other. Now we have to show that BB minus A equal to 4, and these two lines given that intersect each other. Therefore, we find the value of lambda and mu and put in the third equation. It should satisfy the third equation because the line intersects. Now solve these equations. Now start it. Now the first equation can be written as 2 lambda minus mu A, that is equal to 5 minus 1 equal to 6, and the second equation can be written as minus lambda minus mu B equal to 1. Okay, and this equation can be written as 4 minus 3 equal to 1, 1 equal to mu plus, and from these three equations, and we can find the value of lambda. Here is value of lambda is equal to 1 minus. Here is given that the element intersect so that 2 the minus a, it means the when the line intersect each other, the value of lambda from this any equation, when we put this value in other two equations, it satisfies the equation. Therefore, we can put this value in equation 2 and the value of lambda in equation 1. We can equalize because lines are intersecting and the value of lambda satisfies both equation. Now, firstly, we put this value in equation 1, put value of lambda in equation 1, and equation 1, that value 2 into lambda 1 minus mu A is equal to 6. Now we can write 2 minus 2 mu minus mu A equal to 6, and that is equal to minus mu is taken as common. We get A plus 2 into, we can write 2, 6 minus 2, that is equal to 2. Now here the mu will be equal to 4 over A plus 2 over minus 6, and minus is written as above. Now here the put this value in equation 2. Now put this value of lambda in equation 2, we get minus lambda means minus lambda in minus 1 minus mu. We put the value lambda here, minus mu b equal to 1. We get minus 1 plus mu minus mu b equal to 1. And that is mu will be equal to 1 minus b equal to minus 1 plus 1 equal to 2. That mu will be equal to 2 over 1 minus b. And this mu value will be from the equation 3 and 4. 3 and 4, that the three equations become equal. That's minus 4 over a plus 2 equal to 2 over 1 minus b. Now we cross multiply, we get minus 4b minus plus 4b minus 4. We multiply by minus 4 and then it's equal to 2a plus 4. We can write this. Now that value, it would become 4b minus 2a equal to 8, and taking divided this equation by 2, we get 2b minus a equal to 4. And we have to prove 2b minus a equal to 4, and this is 1. Okay. Now go to the next part of this question. Part B, given also that element are perpendicular, find the value of the A and B. Now this line is L and this line is M. Now you know that when element are perpendicular, the direction vector of line L and the direction vector of B, and we write it as a column form 2, -1 and -1. This is the direction vector of line L, and the direction vector of line M is A, B, and 1. And the dot product of these two vectors will be equal to 0, because when two vectors, so this is the vector A and this is direction vector A, and this vector is B and this is direction vector B. The product of A dot B will be equal to 0 when the lines are perpendicular. Here the lines are perpendicular, we see that A 2 minus 1 1 into A B 1 equal to 0. Now we write down to multiply A plus minus 1 into B minus 1B plus 1 into 1 minus 1, that is equal to 0. We get 2 minus B equal to 1. This is the first equation, and second equation is already given here. Now we put this value 2B minus A. 2B minus A is the second equation. Now that this is first equation, and this first equation becomes that B will be equal to 2A minus 1. We shift B from left to right side, therefore B will be equal to 2A minus 1. Now here is we put the value of B in equation 2. Now put the value in equation 2. Okay. Now here it becomes 2 times of B is 2A minus 1 minus A equal to 4. That is equal to 4A minus 2 minus A equal to 4. Here this value becomes 2A equal to 6. 4 plus 2 6, then A will be equal to 2. Now put the value here, we find B. 2B minus A equal to 4, then 2 of 2B minus 2 equal to 4, and 2B equal to 6, and B will be equal to 3. Part C, when A and B have these values, find the position vector of the point of intersection of L and M. And the point of intersection of L and M satisfied both the vector equation L and M. Now to find the point of intersection of L and M, firstly we have to find the value of mu, or either mu or lambda. Now the value of mu, this is the mu equal to 2 over 1 minus 3, we already find out. Now here we put the value 2 over b is 3, now we can write 1 minus 3, and that value 2 over minus 2, and mu will be equal to minus 1. Now this value put in the equation of vector line L either, and now here we put this. This is the equation of line M. Now here the value of xyz will become 5 plus The value of mu is -1. Value of a is 2. Now we can write it 2. 4 plus -1. The value of p is 3. And same is 3 plus -1. And this will be the position vector of the point of intersection. At this value of mu, the line LMN intersects, and we get 5 minus 2, that is equal to 3, and 4 minus 3 equal to 1, and this is the 3 minus, this is plus 3 minus 1 equal to 3. This is the equation x, y, z, and this is the vector form equation. That's position vector of point of intersection is 3i plus j plus 2k. Now the question number 10, the complex number -1 plus square root 7i is denoted by u. It is given that u is the root of this equation 2x cubed plus 3x squared plus 14x plus k equal to 0. If k is the real constant, find the value of k. Now here this number is the root of this equation. This number is noted by you and this is the root of this equation. If this number is the root of this equation, then that p of -1 plus under root 7i will be equal to 0. Then here is the p of x is this 2x cubed plus 3x squared plus 14x plus k, and we put the value p of u here. P of u will be, if the root, then will be equal to 0. Now we put u here in this equation. Now firstly we find the value of x, 2x squared and x, and after this we put this value in the equation. Here x equal to, that's 4. We put here is u equal to -1 plus square root of 7i. Now u square will be equal to -1 plus root 7i into -1 plus square root of 7i. Now we multiply this, we get -1 whole square minus 2 times of plus 2 times of -1 into 7i plus square root of 7i whole square. Now we get -1 minus 49 and plus a square root of 7 is 7i square, and we can write it 1 minus 49 minus I square is equal to -1, therefore that can be written as -7, and we get -6 minus 49 plus u square. Now next we find the u2. u2 will be equal to u into u square. U is -1 plus square root 7i into u square is -6 minus 2 times square root of 7i. 1 multiply -6 is +6. -1 multiply -2 plus 2 square root of 7i. And then plus square root of 7 minus 6 times square root of 7i. Then -7 multiply -2 square root of 7, we get -2 into 7i square. Therefore 6, we can write it 6 minus 2 7 are 14 I square, and that is -4 square root of 7. Now 6 minus 14 minus 1. I square equal to minus 1. Therefore, minus 4 square root of 7. That is 6 plus 14, that becomes 20 minus 4 square root of 7. Now we put these values in this equation. This is the question 1. Now we put 2 into u2 is given here with 20 minus 4 square root 7I in plus 3 into u square, that is u square, minus 6 minus 2 square root of 7I plus 14u, u is given here, minus 1 plus square root of 7I plus k equal to 0. Now we can write this, that is 40 minus 8 square root of 7I minus 18 minus 6 under root 7I and plus 14, that minus 14 minus plus 14 square root 7I plus k equal to 0. Now 40 minus 18 minus 40. Here we have 14 minus 18 and minus 14. That will become 48 and 4, 12 and 32, and that is minus 32 and 40 minus 32 equal to 8. And minus 8 minus 6 minus 14 minus 14 plus 14 will be cancelled. We get 8 plus k equal to 0. And then k will be equal to minus 8. This is the answer. Now the B part, find the other two roots of the equation. Find the other two roots of the equation. Here this equation is a complex, the roots of this equation is a complex number. If one root is a complex number, then the other root will be the conjugate of this number. Therefore, alpha is the number minus 1 plus k root 7I. Then its conjugate will be beta equal to minus 1 minus k root of 7I. And we find the equation by using these two roots. Sum of roots alpha plus beta will be equal to minus 1 plus k root of 7I plus minus 1 minus k root of 7I. Okay. Now this value becomes minus 1 and minus 1 plus k root of 7I minus k root of 7I will get minus 2. And same as the product of the roots alpha beta minus 1 plus k root of 7I into minus 1 k root of minus 7I. And we can apply the identity of plus p into a minus p, that's k square minus 1 square minus 7 k root of 7I whole square. Now we get minus 1 square is 1 minus 7 square root of 7 square root 7 square will be minus 7 and I square will be I square, and that value becomes alpha plus beta 1 minus 7 minus 1, and that will become 1 plus 7 is equal to 8. 1 plus 7 equal to 8. Now the question for from these roots we can find a quadratic equation x squared minus sum of roots plus product of roots equal to 0. Now we can write it as x square minus sum of roots minus 2 into x plus product of roots is 8 equal to 0. And this equation x square plus 2x plus 8. And this is the one of the factor of this given equation. This will be the factor of this given equation. And the equation is 2x cubed plus 3x squared plus 14x and plus k is 8, we put here 8, and the one of the roots is this x squared plus 2x plus 8. Now the other roots will be equal to x plus b, and that will be equal to x cubed, and we see that here the value, and that is equal to 2x cubed plus 3x squared plus 14x plus k is 8. Now we can find the other factor a and ax plus b. And we multiply this equation, we get ax cubed. Okay. Now that's equal to ax cubed plus bx squared plus 2ax. That will multiply this 2ax squared, and that 2bx plus 8a, 8ax plus 8b, and that is equal to 2x cubed plus 3x squared plus 14x. Now here is a is equal to 2. Now we see that x cubed 2 is equal to a is equal to 2. Now we compare the coefficient of x squared. Firstly, we compare the coefficients q and x squared. Here the coefficient of here is the x squared b plus 2 of a into x squared, and that is ax cubed. Now here is 3x cubed plus 3x squared plus 14x plus k. We compare the coefficient of x cubed, a will be equal to 2, and b plus 2 times of a equal to 3. Therefore, we put the value of a here. Now we get b plus 2 into 2 equal to 3, and e will be equal to minus 1. Now the next factor will be equal to 3x. Ax plus b, and that is equal to a is there is 2x minus 1 equation. Now we already find the root of this equation is that first root is minus 1 plus square root of 7i. This root is already given in this question, and this next is the conjugate of this root, and the third will be 2x minus 1 equal to 0, that will be equal to x equal to 1 over 2, and this is the third root of the equation. Okay, now we go to the next part. On an Argand diagram, sketch the locus of point representing complex numbers z satisfying the equation z minus 2 equal to 2. And we already given in this question u is equal to minus 1 plus square root of 7i. Now we put this value in this equation, we get minus 1 plus square root of 7i, and that equation represents the locus of the circle. And this point, this is the z, we suppose this is the z naught, and this is minus 1 plus under root 7i, and we take it, and this value represents the center of the circle. And the center of the circle is minus 1 in square root 7, and the 2 it represents the radius of the circle. Radius is 2 here. Now The square root 7 value is 2.645, and we write it 2.465. Here we can write this value minus 1, 2.645, and the radius is 2. Now we got a locus here. This is the now the center of the circle is minus 1, 2.645, minus 1 and minus 2.6 in this 2.5 and just above the 2.5. This point is the minus 1. This point is the center of the circle. Now the radius is 2. Now we take 2 units below and 2 units on right side, and this 1 and 2, and same as 2 units above. This is 1 and same as 2 units on right side. Now we join this. Okay. And this is the locus of the point representing complex number. And that point is the center. And this is the center minus 1, 2.645. And this locus shows the complex number set. Okay. Now the next part of this, determine the greatest value of argument set 4 points on this locus giving the answer in value. We already draw the locus of set, and this is the locus of z. And to find the greatest value of argument z, we draw two changes. One is from, and it touches the circle at this point. And next tangent, it touches the circle at this point. We see that that tangent will be the greatest angle. And the argument z at this point, the value will be greatest. Now we find this angle. And this is the total angle we have to find. We see that this is the radius of circle, and the radius of circle always right angle to the angle. Now to calculate the angle, we split this. After this, we can calculate this angle, and, and this is the second angle we have to find. And total angle will be equal to 90. Sorry, pi over 2 plus, and that angle we suppose that this is the angle theta 1, and this is the angle theta 2. Total angle will be equal to theta 1 plus theta 2. And this is the total angle we can find the argument z, argument z will be equal to pi over 2 plus theta 1 plus theta 2. Okay? These points show this is the C, and suppose that this point is considered as E, and that point also considered as Q. You see that there are two triangles. One triangle is CPO, and other triangle is OCQ. OQC. These are the two triangles. And from these two triangles, we can find the angle theta 1 and angle theta 2. And we make these two triangles separately here. And this length CP is the radius, and the radius of the circle is given above. Now this is the radius 2, and we write it. Now this is the right angle triangle, and from this right angle triangle CPO we can find the angle theta 2. Now firstly we have to find this length OC. Now to find the length OC, we know that x2 minus, we use the formula x2 minus x2 whole square, that is minus 1 minus 0 whole square plus square root of 7 minus 0 whole square. Now, on the calculator, we can calculate it. This answer is OC square, and then OC square will be equal to 1 plus 7, 7 equal to 8. OC will be equal to square root of 8. And we can write 2 square root of 8. And from this length is 2 square root of 2. Now we use the trigonometric ratio here, that is opposite our hypotenuse, that is sine theta 2 will be equal to 2 over 1 over 2 under root 2. Now the theta 2 will be equal to sine inverse 1 over square root of 2. Now we take sine inverse 1 divided 2, we put the value in the calculator, we get 1 5 over 4 is 10. 5 over 4. And to find theta 1, here we see that this is the length square root 7, because from A to A is square root 7, and the value is square root 7, and that length is 1. And we can write it as 1. Now that is opposite, so it doesn't. Now 1 over square root of 7, that is equal to theta 1, and that is can be written as tan inverse 1 over root 7. Now we put the value theta 2, and we put this value in this equation. This is the argument there, and that will be equal to the angle is 90 degrees, power 2, plus theta 1 is tan inverse 1 over 7, plus this is theta 2, so this theta 2 is 5 over 4.